All right, because 7b is so long and we've been working on this for so many days, I'm going to just put up all the answers and then I'll work through it. So take a look at this. You can pause the video right here so you can look at 5 through 8. And here you go for 9 through 14. So pause the video so you can compare your answers. Star them if you had anything wrong and you want to ask questions. And then the last 4. And then I will go through them. So let's get through these. This was an 11 here. I changed that in class to an 11. So if you didn't have that, make sure you write that down on number 8. All right, number 7. Always look to greatest common factor. Number 5 does not have a greatest common factor. It is a trinomial, 3 terms. So I'm going to jump straight into 3 times 21, so a times c, 63. When you do all the factors, you're looking at negative 9 times negative 7 is the factor we need. That's going to multiply to positive 63. That's going to add up to negative 16, which is your b. So that's what we're looking for. Jump straight to the Punnett square at this point. A term goes in the top left, C term bottom right, and the negative 9 and negative 7 go into other 2 squares. Remember, they have to add up to the middle terms, so negative 9x squared and negative 7x squared. And the greatest common factor of the bottom row is 3. The 9's negative, so it'll be negative 3. The top row is x squared. The first column is also x squared. With the 3 and 3 and the 9, we have 3x squared. And the last column is 7. Because the 7 here is negative, we'll bring a negative with it. I'm going to rewrite our factors, 3x squared minus 7, and x squared minus 3. And you cannot factor these any further. They're not difference of squares. You cannot square root either one of those binomials. All right, number 6, this is a cubic binomial. So what this is going to look for, this is going to be sum and difference of cubes. Is there a greatest common factor? No, so let's move on. Cube root of x cubed is x. That is actually going to be your a in the formula. Cube root of 8 is 2. That is going to be your b in the formula. This is a difference of squares because there's a subtraction, so difference of squares. So we have a, same sign, minus b. I don't know where that 3 came from. A squared, opposite sign, so a times b. Always positive, b squared. Now let's look to simplify each term. So x minus 2, there's nothing to simplify there. We have x squared, which is x squared. X times 2 is 2x, and 2 squared is 4. And there is your factors. That would multiply 2x cubed minus 8. Looking at our next problem, we have 8x cubed minus 1, no greatest common factor, so we'll move on. You can see it's a cubic problem, so we're looking at sum and difference of cubes. Well, it's difference because of subtraction. Cube root your first term to get your a, cube root your second term to get your b. After we do that, we're going to substitute each one of these into the formula. So we have a, and then same sign, so subtraction, a minus b. We do a squared, opposite sign, a times b, always positive, b squared. And then look to simplify each term. 2 minus 1 is 2 minus 1. There's nothing to simplify there. We have 2x squared. That's the term. 2x squared means 2x times 2x, which is 4, ends up being 4x squared. Or you're squaring the coefficient and the x is really what we're doing. 2x times 1 is 2x, and 1 squared is 1. There's your factors. C, looking at there, we have, is there a greatest common factor? No, it hasn't been yet. Cube root the first term is 3x, that's your A. Cube root of 64 is 4, that's your B. We have 3x, well, we have the same sign. This is sum of cubes, so same sign, b, a squared, opposite sign, so subtraction, a times b, always positive, b squared. Look to simplify. Nothing to do with a binomial. We have 3x squared. So 3 squared is 9 and x squared is x squared. Or you could think 3x times 3x. The middle here, 3x times 4 is 12x, and 4 squared is 16. And there you go. All right, let's get to number 7. It's kind of weird, it's off to the side here, but I have 4 terms. When you have 4 terms already set out for you, just put it straight into, try to put it into the Punnett square, and it should work. First term, top left, last term, bottom right. The other two don't matter. It's weird that they don't match up, but they don't with the xy's. In this unit, this is going to work this way. Bottom row, you have 2 and no x, with the 4 is negative, so it's a negative 2. Top row is going to be just x. First column is 2x, and last column is just y. And since it's a positive xy, this is going to be a plus. So we have 2x plus y times x minus 2. All right, number 8. Remember to change that negative 6 to a minus 11. So make sure to change that. Otherwise, you cannot factor it, which is a possibility. It's not a terrible thing to do, to know, but you cannot factor if it was a negative 6. It's not factorable. If I was a mean teacher, I would have that. Like my teachers had problems that weren't factorable. Just know that not every trinomial you can factor. But anyways, here, 2 times 9 is 18. And what two numbers multiply to 18 that add up to negative 11? Well, this is where we got to be kind of careful. It's 2 negatives multiplied to positive, and to 2 negatives will add up to be a bigger negative. So there we go, negative 2 and negative 9. So we have first term, top left, A term, C term, bottom right. The middle term is going to be negative 2 and negative 9 with the xy on it. Negative 2xy, negative 9xy. Look at your greatest common factors of the bottom row. Y, the first term is negative, so negative. Top row, x. First column, 2x. And last column, 9y. And because the 9 is negative, we'll pull a negative out. 2x minus 9y, x minus y. All right. So sad, erasing all this, but we'll go over it. Number 9, we have, it's a trinomial, so we're thinking A times C. Well, first, is there a greatest common factor? No. I seem to be forgetting about that. There's no greatest common factor, so we move on. A times C is 5. What two numbers multiply to 5 that add up to negative 6? Well, you have 5 and 1 add to 6. Negative 5 times negative 1 multiply to 5, and they add up to, wait a second. They add up to negative 6. So there we go. There's our numbers. Put them in the Punnett square. First term, top left. Last term, bottom right. And negative 5xy. And negative 1xy. Bottom row, greatest common factor is y. They share a y. And because the first term is negative, we pull it out. Top row looks like it's just an x. First column, 5 and x. And last column, we have just a y. And because that one's negative, pull a negative out. So rewrite what we have, 5x minus y. And x minus y. They're your factors. 10. Again, same type of problem. We have a trinomial, 3 terms. And so we do A times C. And you do what two numbers multiply to negative 30 that add up to 7. That adds up to negative 29. Negative 10 and 3. That has a positive 7, so it's probably negative 3 and 10. There we go. That's what we're looking for. because negative 3 plus 10 is positive 7, and that's negative 30. So that's what we're looking for. So let's use the Punnett square. First term, A term top left, C term bottom right. The negative 3, make sure it has to add up to the middle term, so negative 3xy and 10xy. Look for your greatest common factor of the bottom row. That's 3y. Because the 3 is negative, we're going to put a negative out. Always if that first term is negative, bring a negative out. Top row is 2 and 10 is 2. You can divide them both by 2, and the x squared and x is x. First column is 1x, or just x. 10 and 15 is 5, and then x, no, y, yes, the smallest of the exponents is y, are the variables. And 10 is positive, so it's going to be a plus. So x plus 5y, 2x minus 3y. All right, number 11, trinomial. So is there a greatest common factor? No. One of these times there will be. You do a times c is 8. What two numbers multiply to 8? That would add up to negative 9. Well, it seems like this is keeps repeating. That's positive 8. It's always these negatives. And it adds up to negative 9. So those are your numbers you want, or we want. One of these times I'll draw a nice square. A term top left, C term bottom right. Always has to add up the middle term, the other two blanks, so negative 1 from here, x squared, negative 8, x squared. And now we're looking at greatest common factor of the bottom row. There isn't one besides 1. Because negative 1 is 1, negative, pull it out. Top row is x squared. First column is x squared. Last column is 8. And because that first term is negative, we're going to pull a negative out. We have x squared minus 8 and x squared minus 1. Now, you got to be careful here, because we're not quite done on this problem. We're going to look at each individual binomial. Because there's a square still, there's a possibility we can factor these further. So we're looking for difference of squares, it's called. So first thing you need to look at is we need to see, is there a subtraction? Yes. All right, cool. So there's a subtraction. I'm just looking at the x squared minus 8 right now. Then can you square root the first term? Yes. Can you square the second term? No. So this is not factorable any further. Now we're going to look at our second binomial. Do we have a subtraction? Yes. Can we square it the first term? Yes. Can we square it the last term? Yes. Perfect. We can factor this further. So we have the square root of the first term is x. So I'm just going to write down 2 sets of parentheses, room for 2 binomials. Square root of x squared is x, so I write x in the first spots of the binomials. Square root of 1 is 1, so I'm going to write those in the second blanks. One of the factors is going to be a plus, one is going to be a minus of this difference of squares. And that is your final answer. All right, number 12, we have a binomial, but we have cubes, so this is going to be a difference of cubes problem. Is there a greatest common factor between the two? No. So we're going to go into cube root. Cube root of 27x cubed is 3x. That's your A. Cube root of 8 is 2. That's your B. In the formula, we have A, same sign as it started with, so subtracting B. A squared, opposite sign, A times B. Always positive, B squared. We have 3x minus 2. 3x squared, simplify that, is 9x squared. 3x times 2 is 6x, and 2 squared is 4. All right, moving on to number 13. So it's a trinomial, so we're going to do A times C. So 2 times negative 3 is negative 6. What two numbers multiply to negative 6? That'll add up to positive 1. Well, 2 times negative 3 is negative 6, but that adds up to negative 1. So that doesn't quite work. We got to get positive 1. So you're really just going to change the signs. That's all you got to do. 2 times 3 is negative 6. Negative 2 plus 3 is 1. That's what we want. Let's put it into the Punnett square. One of these days I'm going to get a square. A term top left, C term bottom right. The other two numbers we came up with, negative 2 and 3, are going to go in the middle with the x squared. So negative 2x squared and positive 3x squared. Bottom row is going to be 1 negative because of the 2. Top row is x squared. First column is x squared. Oh, 2x squared. Don't forget the 2. And the last column is 3. I'm going to rewrite this. This is pretty ugly looking. So 2x, it's a positive 3 because of the positive 3 here. So 2x squared plus 3 and x squared minus 1. Look to see, can we factor these? I see squares in here. So this could be a difference of squares problem. Can you, well, first I see a plus, so that we cannot factor this any further. It has to be a subtraction. That's the number one stipulation. It has to be a subtraction. So like on the second binomial here, we see a subtraction, perfect. Can we square root the first term? Yes. Can we square root the last term? Yes. So we're gonna square root the first term, that's x. So in both my binomials, I write x. And can we square root 1? Yes, that's 1. And one of the factors is going to be a plus, one's going to be a minus. And there's your final answer. Number 14. Here is the first problem where we have a greatest common factor. The GCF. Greatest, biggest number you can divide out of both is 2, both terms. So the GCF is 2. So what we're going to do is you're going to divide. It's undistributing the 2 out. Now we're going to concentrate on just what's in the parentheses. Can we factor this further? And the answer is most likely yes. We have a difference. I see a cube, so can we cube root the first term? Yes. That's your A. Can we cube root the second term? Yes. That's your B. So if you can cube root both terms, then it's a sum or difference of cubes. The 2 is going to stay on the outside. And then what's on the inside, or the factors here, this is going to be from the formula. So you do A, same sign. So it's A minus B. It's A squared, opposite sign, A times B, always positive, B squared. Let me put those parentheses a little bit bigger. All right, copy down what we have. Simplify everything. Nothing to simplify yet. We have 2x squared, so we have to do that operation, that's square. So 2x squared means 2x times 2x, which is 4x squared. 2x times 1 is 2x, and 1 times 1 is 1. And here are your 3 factors that would multiply together to get 16x cubed minus 2 if we wanted to multiply it all out. All right, last page. Number 15. It's a trinomial, so we're going to do A times C. So 4 times 25, 100. What two numbers multiplied at 100? That would add up to negative 20. No, neither one of those. 25 times 4, no, that adds up to negative 21. Negative 10, oh wait, negative 29 that would add up to. Negative 10 times negative 10, that's positive 100. Negative 10 plus negative 10 is negative 20. Cool. Greatest, so now we're looking at, should have talked about the greatest common factor right away. There wasn't one. A term top left, C term bottom right. Ooh, that is an ugly Y. We have to add the middle terms up to the B term, so make sure to put X, Y's on them, the variables. Look for your greatest common factor of the bottom row. The 10 is negative, so it's going to be negative 5y. Top row is 2x. First column is 2x, and last column is 5. First term is negative, so pull it up. So you have 2x minus 5 and 2x minus 5. And this is also known as a perfect square binomial. So at the very beginning, you could notice if you can cube root the first term, nope, square root the first term, and square root the second term. You have square root of 4x squared is 2x. Well, here's your 2x and 2x. Square root of 25y squared is, oh, I totally forgot the y. I forgot these y's. It's a good thing I checked. And so that would be 5y. And both of them are subtraction, because you have to multiply to an addition, and they have to add up to a subtraction. So they're both terms are going to be subtraction. All right, number 16, we have 4 terms. 4 terms means let's just put it in the Punnett square, because the Punnett square has 4 squares. First term, top left. Last term, bottom right. The other 2 don't matter where they go, because there's only 2 blanks left, and there's only 2 terms. Bottom row, negative 3. Top row, x. First column, x squared. Last column, negative 5. X squared minus 5, x minus 3. I do see a square, a binomial squared, so we have to look to see, can we do the difference of squares? So we're looking at, is it a subtraction? Yes. Can we square root the first term? Yes, that'd be x. Can we square root the second term? No. Square root of 5 is not a perfect square. So this is going to be, you cannot factor that. And your final answer is here. We don't do anything with the second one because there's no exponent. So there's nothing we can break that down for. There's nothing to break it down to. All right, number 17, it is a trinomial. So let's do a times c. Well, we should first look, is there a greatest common factor? No. So we do a times c. A times c is negative 36. Think about what 2 numbers multiply to negative 36 that add up to negative 5, and that's negative 9 and 4. Punnett square, first term top left, last term c term bottom right. The other 2 numbers go in the other 2 blanks, but with the xy's, because they have to add up to negative 5xy. So negative 9xy and 4xy. Bottom row is negative y. Top row, 2x. First column, 9x. And last column, 2y. The 4 is positive, so that 2 is going to be positive. So we have 9x plus 2y and 2x minus y. And last problem, there are 4 terms. Punnett square has 4 blanks, so let's put them in. 3x to the third, negative 10xy. That's for first term, last term, and the other 2 don't matter. It's really weird, though, that they don't have the same terms in the middle, but they don't. Bottom row is negative 5y. The top row is 3x squared. First column is x. Last column is 2y. It's a positive 6, so that's going to be a positive 2. 3x squared minus 5y. You see a binomial here with a square in it as one of the terms, so we should look to see, is it a difference of squares? Can you square root? Well, it's a difference, yes. Can we square root the first term? No. Can't square root 3. Not a perfect square. So this is just going to be our final answer here. So that's it. All right, please come with any questions.